So, Ms. Avantika, we'll try to understand multiplication of vectors, addition of vectors. Uh, Addition of vectors we can do in two ways. We'll try to understand what are the two ways, and then we'll understand the subtraction. And if time permits, we'll try to understand this part in detail. Yeah.
Yes, sir.
Okay. Any doubt in the last lecture that we had done?
No, sir.
Okay. I'll just review the topics that we had gone through so that we can continue. So see, last time we started with the introduction to XYZ axis. We understood that this is XYZ axis, XYZ. Then we understood the concept of the longest diagonal. We understood a very important concept of unit vectors. We understood that there is a unit vector I, there is a unit vector j, there is a unit vector k. What is a unit vector? A unit vector is a vector whose magnitude is 1. Any doubt about this?
No, sir.
And how it helps us, how the unit vector helps us is, this is what we have done in detail, that if there is a point like say 3, 4, 5 here, 3, 4, 5 here, and using the concept of position vector. So starting from this origin, if I draw a vector like this vector can be written as 3i plus 4j plus 5k. Mr. One thing, any doubt?
No, sir.
Now, when I was in class 11th, when I was trying to understand this concept of vectors, one confusing thing used to be, they used to write this as, at time they used to write it like this, OP. And at time we used to see this vectors written as A vector, B vector, and then they used to do this A plus B. So I used to wonder, where did this I, J, K had gone? Have you understood my doubt?
Yes, sir.
The point is, this 3i plus 4j plus 5k, this vector, I can write this in shorthand as A vector. Are we clear about this? It is just a way of writing the, rather than writing this full, I can just write it like A vector. Are we clear, Avantika?
Yes, sir.
Okay. So we understood the concept of unit vector. We understood what is ijk. We were comfortable with the concept of XYZ plane. Then we spent, though it was not required, we spent 2 minutes discussing this direction cosines. We did some practice problem. And this was another very important topic that we did, resolution of vectors. In resolution of vectors, we did resolution of vectors in a rectangular plane. What we did was that if this is a vector like, okay, this is what we did. If this is a vector, basically what we did was, if this is a vector R, whose magnitude is, another thing that we discussed was how to write the magnitude of a vector. This is how the magnitude of a vector is written. And if this makes an angle theta with the x-axis and a angle and a certain angle with y-axis, then resolution of vector implies that I can break this vector into this vector and this vector. How? We understood that this can be written as r cos theta, and this part can be written as r sine theta. So therefore, I can write my vector r in this format. I can write it as r cos theta I cap plus r sine theta j cap. Ms. Avantika, are we clear till here?
Yes, sir.
Okay, now let us continue our journey forward. Okay. So one is multiplication of a vector by scalar. Now I can have a vector like this. I can have a vector like 3i plus 4j plus 5k, any random vector. If I want to multiply this vector by a scalar implies just a simple number. If I want to multiply this number with a scalar, all I need to do is just multiply this with this, multiply this with this, multiply this with this, and my answer would be 15i plus 20j plus 25k. Is Avantika, are we clear?
Yes, sir.
Basically, what I'm trying to tell you is that, so for example, if I want to multiply this vector with 2, what fundamentally this means is, if this this is a vector, you just increase, you just double the vector. You are making another vector like this. Are we clear, Avantika? You have doubled the vector. Are we clear, Avantika?
Yes, sir.
So multiplication of a vector by a scalar number, by a scalar quantity. Scalar implies any number just having magnitude. So you just multiply that number, and if it is a negative number, you just multiply it with a negative number. So it is very simple. So for example, if this is 3i minus 2j minus 5k, and you are multiplying this with the minus 2, all this means is just change the, basically all this means is change the direction. Multiplying this with the minus 2 means change the direction of the vector in the opposite side and double its size. Am I making myself clear?
Yeah.
So if the vector was running like this, you just change the direction and you double it. Are we clear? Negative implies, this negative sign implies you change the direction of the vector. So for example, if this is a vector, I multiply this vector by minus 1, all it implies is I'm changing the direction of the vector. This is one thing, are we clear till here?
Yeah.
Because I'll be using this when I'm discussing the subtraction of vectors. So multiplying a vector by minus 1 implies just change the direction of the vector. Now, the interesting thing is that this multiplication of two vectors, how does multiplication of two vectors look like? So for example, if there is a vector like 3i minus 2j plus 5k, and there is another vector, let us assume 2i minus 3j. I want to multiply these vectors. So multiplication of vectors is a bit complex. It is in two, it comes in two flavors. One is a dot product, another is a cross product. We'll discuss this in detail, but this is a bit complex product, requires a bit of understanding. I will try to discuss dot product in this lecture, maybe cross product in the next lecture. So let us attack the simple things first. The simplest thing is addition of vectors. I can have these two vectors which would be pointing in the same direction. All I need to do is just add the two vectors a and b. They are pointing in the same direction. So addition of vectors when they are pointing towards the same direction looks something like this. So this is one of the vector, this is another vector, dono same direction mein, so this becomes a resultant vector. This is one thing, are we clear?
Yes, sir.
Similarly, if I want to, they are in the same direction, they are in the opposite direction, I want to multiply. So this would be the net effect. Are we clear?
Yeah.
Okay. I want to add two vectors which are at right angle with each other. What I do, I join the tail of the first vector, with the head of the second vector. I join these two, and this would be the resultant. Mr. Vantika, are we clear?
Yes, sir.
Now this is what is called the triangle law of vector addition. This is what I have done. Now in school exams in terminal, they might ask you this as a theoretical question also. So this is what is called vector addition, and they have given this definition also. Mr. Vantika, are we clear?
Yes.
Okay. Then there is a another way in which the triangle law, it is almost the same way. They are almost cousins. So the second is the parallelogram. The parallelogram looks something like this. So if this is the first vector and this is the second vector, what you do is you make a parallelogram out of this, and then you join this diagonal of the parallelogram is the resultant of the two vectors. Ms. Avantika, are we clear?
Yes.
These are cousins because you could very well have done like this, that if this was a vector and this was b vector, the same would have been the resultant vector. Are we clear, Avantika? Why triangle law and parallelogram are almost the same way of putting the same thing?
Yes, sir.
And that is why they are writing parallelogram law of vector is another way of stating triangle law of vector addition. They are one and the same thing. I'm discussing this because in exams they might ask you this as a theoretical question, so we should be clear. And then this is the bigger brother, the polygon law of vector addition. What does the polygon law of vector addition means? That if you have these random vectors pointing in random directions, so what you do is you start putting these vectors in a polygon like this, and what you do is you join the tail of the first vector with the head of the last vector. Are we clear? I'm sorry, this would be the head. So if you see, this is the resultant vector. And this is what the statement is. You should have a fair amount of idea what the statement looks like. Are we clear one thing?
Yeah.
So addition of vectors same direction, opposite direction, at right angle, at an angle, triangle law, parallelogram, polygon law. Now the issue is, this is what is more important, how to analytically find the length and the direction of the resultant vector. And these are the formulas that we need to learn. I think in one of the previous lectures we had discussed this. The formula is pretty simple. So basically it is a loose version of that a plus b whole square ka formula. So a square plus b square plus 2ab cos theta. Mr. Vantika, are we clear?
Yes, sir.
Okay. So where theta is the angle between the two vectors, the vectors which are under observation. So what I'm trying to tell you is that this is my first vector, this is my second vector, this is the angle theta which is between them. I'm sorry. The angle between them is, this is the angle between them. This is the theta. And what you need to remember is, and what you need to understand is, so this is the first vector, this is the second vector, this is the resultant, and this angle is beta. The beta angle which is given in the formula is the beta angle which is given in the formula is the angle of the resultant vector. So if you see, this is the angle of the resultant vector. This theta is the angle between the two vectors, this vector and this vector. Mr. Vantika, are we clear?
Yeah.
So length of the resultant vector, length of the resultant vector is given by a square plus b square. What is a, what is b? Or you can, in this case, it is absolutely okay, you can write this as p and q also. So p square plus q square plus 2pq cos theta ka square root, where p and q are the length of the two vectors. Ms. Avantika, are we clear till here?
Yes, sir.
And similarly, we can find this angle beta also. The formula which is given is for tan of the angle. Once we calculate the tan of the angle, we put the values. So this is the formula which is given to us. We put the values here. This p and q, they are the length of the vectors. We put the value here. So whatever. So for example, if tan beta, let us assume tan beta comes to be, let us assume 1. So beta would be 45 degree. Mr. Avantika, clear?
Yes, sir.
Okay. So this part, this is where a lot of questions come, and this is how the questions usually are asked. What is the angle between 2 and 4 and 3 and 4, so that the resultant is 4 and 4. So a spin on the this formula, these two formulas. And another question that you have done just now, let us look at that also. Yeah. Two forces 10 Newton and 6 Newton act upon a body. If the direction are unknown, the resultant force on the body may lie between which limits? So this is a bit complex question, but the point is the formula that is being used is the same formula that we have discussed right now. Are we clear? The best thing about this formula is it can be used for the cases where the angle between the two is 90 degree. So the same formula can be used when the angles between the two are 90 degree. Mr. Avantika, are we clear till here?
Yes, sir.
Okay. So we have done this analytical formula. Okay. Then if we have to subtract two vectors, all I do is, this is a vector, this is b vector. I want to subtract the two. So what I do is, if I want to find a minus b, what I do is I change the direction of b. So this is how I have changed the direction. Same magnitude but in the opposite direction. And then I just add a and minus b. Once I add a and minus b, this is the resultant vector that I get. This is one thing I need out.
No, sir.
This is what they have written here also. So if you want to find p minus q, so this is p, this is q. I have changed the direction of q, and this is the resultant vector. This is all that they are trying to say. Any doubt here?
No, sir.
अरे भाई जोक कौन सुना रहा है?
Nothing, sir. Mom was here.
Okay, okay. I thought your cousin was there or some brother sister was there who was.
I don't have any.
Acha, you don't have any. Okay. Fine, ठीक है.
No.
So I thought somebody might be disturbing you. Okay, nice. So yeah. So this is this part, the unit vector part. This is what we did in the last lecture. Resolution of vector. This is what we were discussing in the beginning of the lecture. Okay. This is what we have done. The same, all this thing we have discussed in the last lecture. Okay. Now let us discuss a bit about the dot product. Just give me a second, 1 second. Can you see the PDF product of two vectors?
Yes, sir.
Okay. So in product of two vectors, scalar product is a simple product. Scalar product is also called the dot product. And the other is a vector product. So scalar is called a dot product, vector is called a cross product. Just remember this. Scalar, other name is dot, vector, other name is cross. Are we clear?
Yes, sir.
This is a simple one. This is a bit complex. This is what we'll do today. This is what we'll do tomorrow. Yeah. Okay. So let's quickly understand because it's simple to understand what is a scalar product. So scalar product, what I do is, so if I have to find scalar product of two vectors, this is the terminology I use. I put a dot between the two vectors, and all I need to do is just write magnitude of A, magnitude of B, cos of angle between them. Am I clear?
Yes.
Let us try to do this with the help of a example so that this makes more sense. Okay, let us try to do this question. Okay, so find the angle between the two vectors A and B, where A is equal to this and B is equal to this. So A dot B is equal to modulus of A, modulus of B, cos of angle between the two angles. So if I am able to find this, then I will be okay with the answers, with the answer. Are we clear, Avantika?
Yes.
So cos theta would be equal to A dot B upon modulus of A into modulus of B. Ms. Avantika, am I clear?
Yes.
Now, yesterday, what we knew was how to find the magnitude of a vector. So the magnitude of this vector would be 1 square plus 2 square plus 1 square. Ms. Avantika, am I clear?
Yes, sir.
4 plus 1, 5 plus 1, 6. This is root 6. If I have to find magnitude of B vector, this would be 1 square plus 1 square plus 4. This would be 1 plus 1, 2 plus 4, root 6 again. Are we clear, Avantika?
Yes, sir.
See, one thing that usually students confuse initially, if I take minus 1 square plus 1 square plus minus 2 ka square, it is the same as saying 1 square plus 1 square plus 2 square. Have you understood what I have said? So, are we clear about this fact which I was trying to explain?
Yes, sir.
I'll take another example. So, for example, if there is a vector like 2i minus 3j minus k, if you want to find the magnitude of this vector, if you want to find magnitude of this vector, it would be given by 2 square plus minus 3 square plus minus 1 square ka under root. This is the same as writing 2 square plus 3 square plus 1 square. Have you understood what I've said?
Yes, sir.
So that is why I did a shortcut and I wrote it directly like 1 square plus 1 square plus 4. And here also I write it like 1 square plus 2 square plus 1. Can you see what I've done? Have you understood it now?
Yes, sir.
Okay. So cos theta is A dot B upon magnitude of A, which we have found to be root 6, and magnitude of B, which we have found to be root 6. So this will be equal to A dot B upon 6. Are we clear till here, Avantika?
Yes, sir.
Okay. Now what? So I hope now we are at least a bit clearer about how this formula works, Ms. Avantika.
Yes, sir.
Now the remaining part, we have understood 50%. 50% of what remains to be discussed is then how do we find this A dot B? How do we find this part so that the denominator part is okay? How do I find this numerator? How do I find this A dot B? So 1, 2 minus 1, 1, 2, I plus 2j minus k, minus 1, 1 minus 2, minus 1, 1 minus 2. Yeah. Now compare this with this and compare this with this. Have you understood what I've said?
Yes.
Okay. Now, basically, my question is how do I find A dot B? How do I find A dot B? So, basically, my question is how do I find A plus 2j minus k dot minus I plus j minus 2k? So, one thing, have you understood what I've said?
Yes, sir.
Okay. Now, let us take help of this textbook and try to understand what the author has done. So, he has just written this AX, AY, AZ, BX, BY, BZ. So, this is what he has written here. And there is a dot in between. This line is the same as this line. Are we clear till here?
Yes, sir.
Okay. Now, what he has recommended is that the answer is the same like opening the bracket of, if you remember class 9th, class 10th algebra. So, x plus y plus z into a plus b plus c. If you remember, this, 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 this. Have you understood what I've said? So it will be
Yes, sir.
xa plus xb plus xc plus ya plus yb plus yc plus za plus zb plus zc. Have you understood, Avantika? The
Yes, sir.
same the same he has done here. You can go through the calculation, but the same he has done here. Now everything is fine. There are just two things that we need to understand. There are two very simple things that we need to understand. One is how do I find I cap dot I cap? Avantika, 1 second. So the two things that we need to understand are one is how do I find this I dot I, and another how do I find this. So once you are understand, if you are able to understand these two, you will be able to understand all of these I, ij, ik, ji, jj, jk, ki, kj, kk. So the logic would be clear. So what is how does I dot I look like? So this would be magnitude of I into magnitude of I into cos of angle between the two vectors. I and I, they both are pointing in the same direction. So the angle would be 0. Am I clear, Avantika?
Yes.
So cos 0 is 1. Magnitude of I vector is 1. So 1 into 1 into 1. Am I clear, Avantika?
Yes.
So I dot I is 1. Similarly, j dot j is 1. Similarly, k dot k is 1. Ms. Avantika, have I made myself clear or not?
Yes, sir.
So wherever you see I dot I, wherever you see j dot j, wherever you see k dot k, that part would be 1. Am I clear?
Yes, sir.
So all this would be 1. Now let us try to understand what is I dot j. Now I dot j, would be equal to magnitude of I, magnitude of j, cos of angle between I and j. Now you will understand if this is I vector, this is j vector. The angle between any two unit vectors is 90 degree. Ms. Avantika, am I clear?
Yes.
So this would be cos 90, cos 90 is 0. So this would be I j 0 is equal to 0. Am I clear?
Yes.
If you apply the same logic, you will understand that I dot j or j dot k or any two unit vectors, the dot product of any two unit vectors which are different, it would always be 0 for a simple reason that I, j, k, all of these vectors are 90 degree with each other. Am I clear?
Yes, sir.
So that is why this is 0, 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 this is 0. So finally, all we are left with, am I audible, Avantika? So all the vectors except these three vectors, everything is 0. And that is why if you see, the final answer is ax bx, ay by, az bz is, that is all that it remains. Ms. Avantika, am I clear or should I explain again?
Can you just explain that again, sir?
Yeah. Okay. What I'm trying to tell you, Avantika, is that I dot j or I dot k or j dot k or j dot I, all of these have a 90 degree between them. Are we clear?
Haan, sir.
Because the angle between two unit vectors is always 90, that is why the dot product of two unit vector would always be 0. Are we clear about this?
Yes, sir.
And that is why if you see the dot products, if you see the dot products closely, what you will find is, if you see the dot products closely, what you will find is that this is 0, 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 this is 0. Am I clear?
Yes, sir.
So very simply put, the final answer would be ax into bx, ay into by, az into bz. And if you are still confused, the good news for you is, all that we are trying to say is that if I take two vectors and I have to find the dot product, very simply, all that I need to do, I took a long route to explain a few things which might be useful for us later. But if I have to find dot product of two vectors, all that I need to do is very simply multiply these two, multiply these two, multiply these two. That is it. So minus 1 plus 2 plus 1 is equal to 0. Am I clear?
Yes, sir.
So what does it mean for our answer? Cos theta is equal to 0 upon 6 is equal to 0. Therefore, theta is equal to 90 degree. Therefore, these two vectors are 90 degrees with each other. Ms. Avantika, am I clear or not?
Yes, sir. Samjha.
What we'll do is we'll do just another numerical and then we'll wrap it off. See, there is a force vector. There are two displacement vectors, R1 and R2. I'll explain what is happening. This is the R1 vector, this is the R2 vector. There is a force acting which displaced the object from first position to the second position. So this is a force vector 2i plus 3j plus 4k. This is a force vector. This force vector, what it did was the object was lying here at the position 2i plus 3j plus k. This was the first position. This was P1. Let us call this to be O. To the position vector R2. This is the second position R2. Yeah. And now we have to find the work done. Ms. Avantika, have you understood the question or not?
Samjha, sir.
Okay. So First thing that I need to understand is what is the formula of work. Work is given by force dot displacement. Are we clear? This is a dot product.
Yes.
And D is the displacement vector. This is the displacement vector. Now, in this case, my first job would be to find the displacement vector. So, what would be the displacement vector? This is what is the displacement looks like. This is the displacement. Now, very simple way of using the triangle law of addition is R plus D is equal to R2. Is this clear what I have written?
Yes, sir.
See, D is the displacement. R1 is the position vector 1. R2 is the position vector 2. Basically, how you can see this is that if I had applied the force from position R1, I would have taken the object to position vector R2 and the displacement vector would be D. Am I clear?
Yes, sir.
Mr. Avantika, कुछ समझ भी आ रहा है या should we do it tomorrow?
आ रहा है sir.
पक्का?
Something similar we are doing in class also.
Okay,
समझ आ रहा है.
fine. Otherwise, if it's an overload, we can do it tomorrow also. Should I continue?
Yes, sir. You can continue.
Okay. So, instead of R, what I write 2i plus 3j plus k plus d is equal to I plus j plus k. Have you understood what I've done?
Yes, sir.
So, my d would be equal to I minus 2i plus j minus 3j plus k minus k. Am I clear? This is I, this is j, this is k, and I'm subtracting 2i, 3j, and k from it. So my final answer would be minus I minus 2j. This would be my final answer. And this would be my displacement vector. Minus I minus 2j. Am I clear, Ms. Avantika?
Yeah.
So I have found the displacement vector now. There's still another step which is pending. So 2i plus 3j plus 4k is my force vector dot product minus I minus 2j. Am I clear?
Yes, sir.
And how do I find the dot product? I simply multiply these two, and this 4. I can write this as 0k, and I multiply these two. That is it. So my answer would be minus 2 minus 6 plus 0 is equal to minus 8. This would be my final answer. Ms. Avantika, is it making sense or not?
Yes, sir. Yeah.
So the work done is minus 8 joules. So tomorrow what we'll do is, Avantika, we'll do some more examples of dot product. And then we'll try to do these few other examples which are based on physics. Is it clear?
Yes, sir.
So if you want to use this formula, the logic, if you know the logic, you don't need to remember the formula. They have used this formula, f dot r2 minus r1. So let's meet tomorrow and try to do dot product as well as cross product. Tomorrow we'll try to finish off this vector part. Yeah?
Yes, sir.
Okay. I'm closing the meeting.
Yes.